I just want to introduce Dr. Ting Wu, Director of pgEd, and also has some incredible research going on in her lab right now with chromosomes. So I'll let her take the podium. Thanks.
Thank you, Joe. Good evening, everybody. I cannot tell you how thrilling it is to see how many people decided to give up part of their evening to catch up with genetics. So thank you for being here. Now, I strongly suspect that many of you are already quite convinced that personal genetic information about yourselves is going to have some impact on decisions you'll make about your life, about your family, or your family-to-be. And as Gina mentioned, we think that some of you may be toying with the idea of having part or all of your genome sequenced. In brief, my guess is that many, if not most of you, believe that genetic information has the capacity to enhance your life, even though it may also complicate your life. Now, I'm in the boat with you. I've been a genetics researcher for over 30 years, and I've been blessed, really blessed, with working with a wonderful group of young people who work very hard together, they play hard together, and we spend a lot of time thinking about chromosomes and inheritance. In particular, my group is focused on how that DNA sequence that Joe mentioned to you gets packaged into what we call a chromosome, and then how that chromosome gets packaged into your cell, and the fact that all that packaging can have a very big impact on how your genome functions. In addition, we think about how the genome evolved, and I have a couple people in my laboratory working on these really mysterious sequences. Some people think they're the most puzzling thing to have come out of the genome project. These sequences are in all of you. They are scattered throughout your genome, and they are really remarkable because they essentially have not changed for 300 to 500 million years. So that's from before the dinosaurs were here. And we don't understand how these sequences have remained so ultra-conserved for so long while the rest of your genome has evolved quite a bit. So those are some of the puzzles we think about. But that is actually not why I'm here today. I'm here because you are just, for every one of you in this room, there are so many people who are not aware of the discoveries being made in personal genetics. And there is a growing sense among geneticists throughout the world that we have a responsibility to make awareness of personal genetics accessible to everybody, regardless of their socioeconomic status, their religious leanings, their political leanings, their cultural background. It's a big task. Now, the goal is not to make it so that people want to avail themselves of genetic technology. It's actually simply to raise awareness so that everyone has a chance to make an informed decision about how they want to use their personal genome, whether they want to use information from their personal genome, even as we all become very aware that there's tremendous diversity of opinion about genetics, and we learn how to respect that diversity. So I am here because I'm a director of the Personal Genetics Education Project, which is a branch of my laboratory. And I want to start off right away and tell you that we would not be here if it weren't for the incredible support of the Department of Genetics and of Harvard Medical School and their belief in this mission of making awareness uniform across our society. I also like to thank Autodesk, which has collaborated with us in a little game I'll tell you about a little later on, and IDT and Genentech. Now, as I said, there are geneticists all over the world with this very same mission, and this is just the logos from some of those organizations. Some of them are dedicated just to genetics, others represent universities, and we've worked with them. It's been a truly very heartwarming experience to see such a convergence of goals. So the goal is to reach people and have them become interested enough in genetics that they become aware. How to do this? Well, I was not trained to work in public education, so it's been kind of a bootstrap experience. And very early on, I learned, along with my team, that facts, especially about something you may not be particularly interested in already, do not stay long in the brain. Furthermore, some facts just bypass the brain. And I know this is true for me when it comes to filling out my tax form. I read and read those directions. They reside for a little bit, and then they're gone. But there is one thing that sticks in my brain. It's quandaries, dilemmas, and problems. They sit in my brain. I can't get rid of them. I go to bed with them. I wake up with them. I think about them all the time. So we thought, maybe this is a strategy. So pgEd has taken that strategy. We focus not on the facts of DNA, what it looks like. Sorry, Joe. They're wonderful facts. I love them. We talk about not only the benefits of personal genetics, but the ethical issues that come with using genetics to try and get at those benefits. So, for example, when we go to classrooms, we spend a lot of time in high school classrooms and in the public forum. We talk about DNA and the use of DNA in law enforcement, the use of sequences to identify criminals and then to incarcerate them. And it does not take more than 60 seconds in a classroom of young people who are thinking to raise their hand and say, there's a problem with all that material, all that information being stored, tremendous potential for discrimination against certain segments of society. And I will tell you that we go to many different kinds of communities, and some communities, the segments of society that are vulnerable to discrimination fill the classroom. Once one of those students or one of the audience raises that question, the conversation is completely, I don't have to do anything anymore. The class takes over, and they start asking questions about DNA and sequencing. So we get ourselves all worked up into how DNA sequence can help us, but how it can be very dangerous. And then we bring in the fact that DNA sequence analysis has also been used to free hundreds of people who were improperly incarcerated. So they're both sides. They're good, and they're good ways to use a tool, but we have to be careful how we use it. We also talk about pre-implantation genetic diagnosis. So pgEd just goes to all these sticky issues. People are very drawn to them. It bothers them or it intrigues them. So pre-implantation genetic diagnosis is a miracle process. It has allowed many people to have children or to have some ability, some control over the genetic makeup of the children that they want to have. So I talk about to the audience how a potential mother will donate eggs. It's put in a Petri plate. Potential father will donate sperm. It's put in the Petri plate with the egg. Embryos are begun. They grow. They grow to the 8-cell stage or a little bit later, at which point a clinician will go in and take one of the cells out. You can see it before you. And that one cell is used to determine the genetic makeup for one or more loci of the embryo that's being grown in the Petri plate. And based on that genetic information, an embryo is selected, either to help parents have some control over the genetic makeup of the children they're going to have, or to prepare themselves for the children they're going to have. All right. This is a miracle for some people, and it's ethically complicated for people. It can be both a miracle and ethically complicated for the same person. And it's a gripping way to introduce the world to this new world of personal genetics. So I was in a classroom once. I was going to show you, but I think I'm tethered to this. So I was in a classroom. It was a crowded classroom. I had literally about 18 inches at the front between the front row of students and the board. And right smack in the middle row, right up front, was a young man who did not stop talking. So I was talking, he was talking. I was talking about genetics. I don't know what he was talking about. But I have to tell you, he was winning the battle for attention. Kids on the left, kids on the right, all paying attention to him. I was trying to engage them in genetics. Brilliant kid, because when I got to this point, he stopped. He turned around, and he had clearly heard every single word I said as he was continuing 2 or 3 conversations around him. And he said, "Lady, this ain't no game." Which is almost the motto for pgEd. And I said, yes. And when he said that, then the class was truly engaged. And the very next question that came up was from a young man in the back to the right, and he said, "I don't care about how this happens." He goes, "I just want to know one thing. Will my parents still love me?" So this is what we think, if some of you are teachers, really engages students and gets them involved in genetics, and then they start asking questions about how it is that researchers can do what they do. We've taken these lessons to Maine, to St. Louis, Missouri, to Galileo High School in San Francisco. I had a wonderful time with these students. They're wonderful wherever we go. Bell Multicultural High School in DC, Boyle Heights in California, and of course we also work here in Boston with the Hinton Scholars Program, and this is the first class that I actually worked with down at the Kennedy Health Careers Academy just down the street. 3 of the young ladies in that group have gone on to in biology and possibly genetics, and CJ, who's in the back in sort of the horizontal striped shirt, has actually come to work with pgEd. It's been a truly rewarding experience. We also run teacher professional development days where we run through the lessons at the pgEd website to help engage teachers and convince them that this is something quite accessible and easy to do in the classroom. Here's a page from our website. Those are the titles of some of the lessons that we have. We go into sticky stuff, reproduction, eugenics, the use of genetics to help guide one's choice in picking an athletic program. Every lesson, they've all been updated. Fresh new 2014 comes with PowerPoints, lessons, exercises, Word documents, links. Pretty much everything is there. Our plan is that you don't really have to go anywhere else. You can go to this site and get what you need, and we'll continue to update them. So what are the exercises about? This is one of the exercises I like to do. We have a sheet that has sometimes 10 very difficult questions. Here are 4 of them. Genetic studies may one day uncover variants that increase the chance of an individual becoming violent. There is such a locus out there that people are looking at with respect to aggression. Question, should the presence of such a variant in a defendant have any bearing on sentencing? What do you think, yes or no? So I hand this sheet out. I was going to do it here, but just didn't get around to it. We give the audience a very short time to answer these questions. You notice it says, do not give your name. We collect the sheets, we shuffle them and hand them back. And then we ask people to raise their hand if the answer to, let's say, the first question that they have before them is different from the one that they give. And that allows the audience to see the diversity of opinion in a room. Question 2, would your answer change if there were a medication that suppressed that variant's influence on aggression? Should that medication be required of anyone that has that variant? Should people be permitted to test embryos for this variant that might be associated with aggression? These are not made-up questions. These are questions that are going to be, they are in people's heads right now, and this is why we feel so compelled to raise awareness of personal genetics in the community. I want to say that it's a two-way street. Researchers and clinicians are very, very eager to engage in conversation. So if you have thoughts or opinions, we definitely need to hear it. It's a group effort, the entire group, the entire world in a group effort. We also have just put up some videos as of this afternoon, I think, of personal stories from people. It's also on our website. They can be matched with some of the lessons. The upshot is that our audience, especially our high school students, go away with the idea that genetics is big. It is really the stuff of life. And we encourage teachers who are in English, history, economics, social studies, health, especially not genetics, to use these lessons, because you don't have to be a geneticist to get involved in understanding genetics and to care about it. I recommend these lessons if you're going to have a family reunion, if you're going to be driving across country in a car with your family. They're really kind of fun. Now, but these lessons are a one-by-one thing, right? We talk to people one at a time. It's a big world and a lot of people. So we have another strategy, which is the entertainment industry. Because movies can reach 20 million people in an hour, and if it's a television series that comes every week, you reach that 20 million people every single week. And therefore, pgEd works with the Science and Entertainment Exchange at the National Academy of Sciences. This organization advises the producers and the writers and the directors of blockbuster movies. We also work with Hollywood Health and Society in LA. They focus a lot more on television programs, and we had tremendous opportunity to work with the Grey's Anatomy team, where, now I have to tell you, it was a learning experience for me. I have an obsession with accuracy and details and fact. But the producers and writers, they know how to get a message across and have that message stick. So working with them was very interesting, and at one point I was reprimanded by the head of Hollywood Health and Society, Sandra Buffington. She said to me, do not think that you're going to be able to go in and change that story. Don't. Try saying that in the way you want to say it. So I took this conversation and I reworded the way I thought would be accurate, and it was horrible. She said, you'll lose half your audience in 30 seconds. But I will tell you, it's been a very good experience. I've learned a lot about what's important and what's not important. And Bailey, I don't know how many of you watch Grey's Anatomy, opened a genome lab. So we're very excited about that. What's another strategy? Gaming. Okay, I'm not a gamer, but we have put out a little game. In this game, if you go to map-ed, don't forget the dash.org, you'll come to our site. You can do it on a computer or on your cell phone. And if you answer 5 questions, you get to pin yourself on the world map of genetic awareness. Now, there's no way anyone does not get 100% on those questions. And we do not keep track of your answers. We don't know who you are. You can map yourself by your zip code rather than your address. So we started this game in Boston, and very soon people started playing it across the world. We were very excited. Thanks to Andrea Lohr, we even got some pins in Antarctica, including the South Pole. I know. Took a little work, that one. The topics, we have a starter game. We have a game on the microbiome that was just launched a couple of days ago. We got 1,000 pins in about 27 hours. We're going to have some on sickle cell, Alzheimer's, alcoholism. We hope they'll keep coming. These games will also tell you some important things. For example, sickle cell anemia. If you have 2 copies of a variant, you will have sickle cell anemia. But if you have 1 copy, it doesn't mean you're entirely safe. You need to watch out and not exert yourself too much. The ApoE4 variant that's associated with Alzheimer's, it is possibly associated, and Bob Gray may be able to tell you more, with bad outcomes with respect to concussion. There is an allele of the aldehyde dehydrogenase 2 gene. If you have it, a lot of Asians have it. If you have 1 copy of it and you drink alcohol, your chance of esophageal cancer goes up. So these games are also meant to pass on important information. But we didn't stop there, because the world, now Joe, we came to the same conclusion. The world is part of the galaxy. Now, I was at a meeting once talking about genetics, and lo and behold, that same meeting, Adam Stelzner, who's the team leader who put Curiosity on Mars, he was talking about Mars. Somehow we were at the same meeting, and I talked to him. He was very interested in genetics, so he played the game, and he pinned himself on Mars. So pgEd is thrilled to be perhaps the first interplanetary educational program. And I urge you to partake in the MapEd game. Now, I bring up space for one, not as for fun, but also because many times in a classroom, students will go to the point of saying that genetics, altering your genome, taking advantage of genetic information, especially when I'm in communities that have experienced discrimination, their families and their lives and themselves have experienced discrimination, there is a great suspicion, perfectly valid suspicion of using genetics. So what we do to break in another idea is that we talk about traveling in space, where the understanding of genetics can be very helpful for protecting astronauts. And it is really amazing how a class will go from really being suspicious of the use of genetics, but then starting to think that there can be miracles of health, and they start to warm up to that, but the idea of altering genomes is complicated, to doing a 180-degree turn and realizing that using genetics to protect people who go into extreme environments may not be a bad thing. It is a complicated, exciting world we're moving into. And then I want to end on one final strategy we're just trying to get going. I hesitate putting this here because we're not quite absolutely sure it's going to happen, but this spring we're going to try and hold a congressional briefing, because our political leadership has tremendous sway in what we think, what we know, what we're made aware of. And so we're hoping to engage our political leadership in helping to raise awareness of personal genetics. And that here we go. There's Washington, D.C. on our website. We're very excited, and here Sion Safai is helping us there. I hope I said her last name right. So that brings me to the end of my talk. I want to thank you for your attention, thank Harvard Medical School for its support, Autodesk, which was critical in getting the MapEd game going, IDT Genetech. And Marnie Gelbart, who's right here in the audience, is in the pgEd program. We work closely with Lauren Tomaselli and Dana Waring. They are the center of pgEd. I don't know what I do. There wouldn't be any pgEd without them. Sion is in Washington, D.C., getting the congressional briefing going. We have a number of wonderful affiliates. And for MapEd, I'd like to thank Dave Bozzi, who is our home-based MapEd expert, Autodesk. A number of people working there with Carlos Olguin, and Neil and Dustin and Mick, who actually wrote the first programs. So thank you very much.